Hello, welcome to my class again. Today I will continue class 10, chapter 10, exercise 10.2. Earlier we have done exercise 10.2, question number 1, 2 and 3, and I have given some hints of question number 6 and 8. Hope you have done, but I found some help. I found some queries about question number 8. So I will try to make you understand. So let us solve question number 4. Question is, prove that the tangent drawn at the end of a diameter of a circle are parallel. So we are drawing this circle. Your question is, a tangent drawn, the tangent drawn at the end of a diameter of a circle are parallel. So here it is a circle, and let AB be the diameter, and now we have to draw two tangents at the end of the diameter. Suppose the PQ and RS are the two tangents drawn at the end of diameter AB. We have to prove that this PQ and RS are parallel. So whatever we have drawn, let us write. Let O be the center of a circle. Here it will be O. AB be the diameter of it. Okay. Through A and B, PQ and RS are the tangents drawn. What we have to show that this PQ is parallel to RS. PQ parallel to RS. So we are trying to prove it. So to prove it, we have to use the alternate angles property. So you see, this is a tangent and this PQ is also a tangent. OA is the radius and OB is the radius, and we know that the line segment drawn from the point of contact to the center of a tangent is perpendicular to the tangent. We got the earlier theorem. So we can say that since the line segment drawn from the center to the point of contact is perpendicular to the tangent. Okay, so we can say that therefore OA perpendicular to PQ and OB perpendicular to RS. So if these two are perpendicular, then we can say that these two angles are 90 degree. So therefore, what we can write? Angle PAO is equal to 90 degree and angle, okay, let it write as OAP. Angle OAP is equal to 90 degree and angle OBS is equal to 90 degree. Okay. Now we will use alternate angle property. Since you see, since angle OAP P and angle OBS are alternate angle. Alternate interior angle angles and they are what? Equal, because each having 90 degree. So if two alternate angles are equal, then their corresponding lines are parallel. Therefore, we can say that PQ parallel to RS. Hence, proved. Okay. Next, question number 5. Prove that the perpendicular at the point of contact of a tangent of a circle passes through the center. Next, question number 5. So I will not show it completely, just I will give the hints. You will do at home. So question number 5 is, prove that the perpendicular at the point of contact of a tangent to a circle passes through the center. Suppose this is circle having center O and this is a tangent AB whose point of contact is P and OP is perpendicular to AB. We have to show that this OP passes through the center. Although it is passed to the center, but we have to prove it. So to prove it, we will draw another line and we will think that it is perpendicular. So this method of probing is called contradictory method. So let's start. Let O be the center of circle and AB be the tangent. At P, that is P is the point of contact. OP perpendicular to AB. OP perpendicular to AB to prove that, but to show that OP passes through the center only. So as it is written here, probe, so we will write probe it. So center O. So to probe, we will use contradictory, CON, contradictory method for probing the above. Okay. So to probe this, we will let another perpendicular. Let assume another line O dash P, O dash P perpendicular to AB at P. We are thinking that another line O dash P is perpendicular to AB at P. So if it is perpendicular, then it should be also 90 degree. Now we will write that since OP perpendicular to AB as given, therefore what? Angle OPB is equal to 90 degree. This 90 degree, this is also 90 degree, and as OP O dash P perpendicular to AB as assumed, therefore O dash P V is equal to also 90 degree. Okay. But it observed that here we are observing clearly OPB is greater than O dash PV, because in the same side of the perpendicular line both angles are having, and OPV is greater than O dash PV. But it observed that OPV is greater than O dash PB, O dash PB. Therefore, our what we can say that our assumption was wrong. So here you see, as we have given OP perpendicular to AV, so OPB is equal to 90 degree, and as we have assumed what O dash PB, O dash P is perpendicular to AV, so O dash PB is equal to 90 degree. But as we are observing, OPB is greater than O dash PB, so our assumption was wrong. Therefore, you can say that OP perpendicular to AV only. That is, OP passes through O. Okay, that is proved. So we can write here, if it is not visible, therefore OP passes through the center O. Proved. So question number 5 finish, and 6 you have done. Last day I have given hints. Now we will go for question number 7. So question number 7, what? Two concentric circles are of radii 5 cm and 3 cm. Find the length of the chord of the larger circle which touches the smaller circle. So let us do this. Try to solve this question number 7. So you are looking this books, textbook mathematics class 10, and we are doing these sums from page number 239. Question number 7. Two concentric circles are of radii 5 cm and 3 cm. That is, two circles having the same center. Same center. Let O be the center of the two concentric circles, and AB be the tangent to the smaller circle at P. You see, if these are concentric circles, then one should be smaller and one should be larger. So let us start. Let O be the center of two concentric circles two concentric circles, AB with the tangent at P, that is, P is the point of contact of the tangent AB of smaller circle. Which is what? The chord for the larger circle. So now what is given? Given radii of two circles are 5 cm and 3 centimeter. You see, if we join OA and OP, then OA will be the radius of the larger circle and OP will be the radius of the smaller circle. Given OA, sorry, before that, if we join this, join OA and OP. We are doing this simply. Given OA is equal to, because it is visible that simply OA is the radius of the larger circle. OA is equal to 5 centimeter. OP is equal to what? 3 centimeter. Now what is to find out? We have to find out the length of the chord of the circle. To find AV, we have to find out the length of the chord of the larger circle that touches the smaller circle. Okay, this one. So here we are getting the theorem or the properties of chord and tangents both. So since AB is the tangents of smaller circle, therefore what we can write? OP is perpendicular to AV. So if OP is perpendicular to AV, therefore in triangle OPA, angle P is equal to 90 degree. So if angle P is equal to 90 degree, then we can use Pythagoras theorem. OA square OP square is equal to OA square. Pythagoras theorem we are using. So AP is what? We don't know. Plus OP 3 centimeter square is equal to what? 5 centimeter square. Now what is becoming? Therefore AP square is equal to what? 25 centimeter square minus 9 centimeter square. So implies AP square, AP is equal to root over of what? 16 centimeter square. Okay. Therefore AP is equal to 4 centimeter. If AP is equal to 4 centimeter, then using the properties of chord, we can find out the length of AV. In class 9, we studied that a chord and the perpendicular. Learned about chord and perpendicular of a circle. In a circle, if AB is the chord and line segment drawn from the center of the chord bisects the chord. The line segment drawn from the center to the perpendicular to the chord bisects the chord. So this AP is equal to BP. So here we can say that since AB is the chord for larger circle, therefore what can we write? AP is equal to BP. Therefore AB is equal to twice of AP, implies 2 into 4 centimeter, that is 8 centimeter. So what we are getting? The length of the chord is equal to 8 centimeter. So here we have completed question number 7. And in last class I have given some hints. I had given some hints for question number 8, but from your end some request came, so we are doing this again. Now look at the question number 8. Question number 8. A quadrilateral ABCD is drawn to circumscribe a circle. Prove that AB plus CD is equal to AD plus BC. Earlier I said that we will use here the theorem of two tangents drawn from external point. Okay? So let us draw simply the diagram. Here, as it is given in the question, ABCD is a quadrilateral drawn to circumscribe a circle at P, Q, R and S. So we have to show that AB plus CD is equal to AD plus BC. So given question number 8, given ABCD is a quadrilateral circumscribed a circle with center O. Touches the circle at P, Q, R and S. P, Q, R and S. So right here P, Q, R and S. To prove that, what is to prove? AB plus CD is equal to AD plus BC. So to prove that, we will use the theorem of tangents drawn from an external point. So right here we know that the tangents drawn from an external point are external point of a circle equal. You see here we can consider AP is a tangent and AS is a tangent. So AB is a tangent, AD is a tangent drawn from external point A. BA is a tangent, BC is another tangent drawn from external point B. And like this BC and CD and CD and AD. So though these tangents are drawn from external point A, B, C and D respectively. So if we consider AP is tangent and AS is a tangent, so we can say that what we can say? AP is equal to AS. AP is equal to AS. Like this. BP is equal to BQ. BP is equal to BQ and CP is equal to CR and CP is equal to CQ is equal to CR and DR is equal to what? DS. DR is equal to DS. Question number 1, 2, 3 and 4. But as we have written here in anti-clockwise, AB, AS, BP, BQ, CQ, CR and DR, DS. But here one thing you remember, in this third line, CQ is equal to CR, you write it as CR is equal to CQ. To prove that line AB is equal to AB plus CD is equal to AD plus BC, we have to remember this point. So now if we add 1 and 2, 3 and 4, mean all. So adding 1, 2, 3 and 4, we get what we get? Left side plus left side and right side plus right side. AP plus BP plus CR plus DR is equal to AS plus BQ plus CQ plus DS. Non-linear diagram. So simply rub it. So if we add these two, AP plus BP, we are getting AB. CR plus DR, what we are getting? CD. And AS plus BQ, AB, CD. AP plus CR plus DR and DBC and S plus DS. Simply just to change here one mistake. AP AP plus BP, CR plus DR is equal to AS plus DS, here BQ plus CQ. Okay. Just I forgot this one. Then AP plus BP, AB, CR plus DR, what? CD is equal to AS plus DS, AD, and BQ plus BQ plus CQ, BC. You see, here it was inside circle A, B, C, D. Here it was P, P, Q, R and S. You see, AP plus BP, what? AB, BQ plus CQ, BC, CR plus DR, what becoming? CD, and AS plus DS, AD. So, your question was this line, it is already proved. Hence, it is proved. Now, for you, I am giving homework question number 9. Now, let us try question number 10 to complete here in this class. Question number 10, prove that the tangent between the angle between the two tangents drawn from an external point to a circle is supplementary to the angle obtained by the line segment joining the points of contact of the center, at the center. Here, the angle between the two tangents drawn from an external point of a circle. Let P be an external point of a circle with center O. Let P be an external point of a circle with center O. That is, O is the center of the circle and P be the external point of it. AP and BP are two tangents. AP and BP are two tangents drawn from that is external point P. You see, here we have already drawn these two tangents. A is the point of contact and B is the point of contact of AP and PP respectively. Then what is to prove? So if we make another angle here at the center from the point of contacts, the angle formed at the point center and the angle formed at the external point are supplementary. We have to show this one. OA and OB are joined, forming angle AOB. If we not join this OA and OB, this angle AOB will not form and we cannot prove the theorem, question. Now, we got the angle AOB. To prove that, what is to prove? Sum of this angle and that APB angle, AOP and APB, sum of AOP and ABP, APB is equal to 180 degrees. That is, this angle and that angle are supplementary angle. We have to probe 180 degree. To probe this question, we'll take help the theorem of theorem number 1, 2. Earlier we have proved that in a circle a tangent is given, line segment joined from the center to the point of contact is perpendicular to the tangent. So here also AP is the tangent, O is the line segment joining from center to the point of contact. So here simply OAP is equal to 90 degree we will get. So simply we will write this thing, since the line segment, since AP and BP are tangents at A and B. Therefore, angle OAP is equal to angle OBP is equal to what when we say 90 degree. Okay, since OA perpendicular to AP and OB perpendicular to what? BP. So now in quadrilateral, if we consider this quadrilateral AOBP, now in quadrilateral AOBP, if you consider this a quadrilateral AOBP, angle AOP, AOB, we are getting this is an angle plus angle A, simply angle A plus angle AOB plus angle B plus angle what? APB is equal to 360 degree. Okay, sum of 4 angles of a quadrilateral is 360 degree, but here you see OAP, what we are getting? OAP 90 degree and OBP also 90 degree, because OB and OA and OB are perpendicular to AP and BP. So simply put the value 90 degree plus AOB plus 90 degree plus APB is equal to 360 degree. So AOPB plus APB is equal to what remaining? 360 degree minus 180 degree. So you can say that angle AOB plus angle APB is equal to what? 180 degree. Now you know, if the sum of two angles is 180 degree, then the angles are said to be supplementary angle. Hence, the angles are supplementary. It is proved. Okay. So question number 10 finished. 8, 9 you will do at home. If you feel any problem, then you may contact with me. Question number 11. Now we will try to solve question number 11. prove that the parallelogram circumscribing a circle is a rhombus. That is, you have given a circle a parallelogram, and we have to prove that this parallelogram is nothing but a rhombus. Now we will use the property of rhombus and parallelogram. We know that in a parallelogram, opposite sides are equal, and in a rhombus, all the sides are equal. In parallelogram, opposite sides are equal, and if this parallelogram having all the sides are equal, then we can show that this parallelogram is a rhombus. So here given a circle suppose this is O, center of the circle, and ABCD is the parallelogram. Circumscribe the circle. Your question is, prove that the parallelogram circumscribing a circle is a rhombus. So let O be the center of a circle, and A, B, C, D be the parallelogram. Be the parallelogram circumscribing the circle which touches the circle at P, Q, R and S. Touches the circle at, you see, AB touched at P, Q and S. AB at P, BC at Q, CD at R and AD at S. We have to prove that this ABCD is a rhombus. Circle at P, Q, R and S. We have to prove that. To prove that ABCD is a rhombus. So to prove this, we will use the property of parallelogram and a rhombus. Proof. Here no need of any extra construction. Proof. Since AB is ABCD is a parallelogram. So if ABCD is a parallelogram, then what can you say? Opposite sides are equal. So AB is equal to opposite side is CD, and AD is equal to BC. This is equation number 1. This is equation number 2. It will use in later. So now another theorem we will use here. Just we proved that tangents drawn from an external point of a circle are equal. So if we say AP and AS are two tangents drawn from an external point A, like this external point B, C and D. Then we can say that AP is equal to AS, AB is equal to BP is equal to BQ, like this and so on. So since tangents drawn from an external points, from an external point are equal. So we can say that AP is equal to BP, like this. AP is equal to AS. AP is equal to AS. BP is equal to BQ. And earlier I said this third line will change something. CR is equal to DR and what? CR is equal to DR. CR is equal to CQ and DR is equal to DS. DR is equal to what? DS. So if we add this as we have added earlier, before that we mark this 3, 4, 5 and this is 6. So if we adding 3, 4, 5 and 6, what we are getting? AP plus BP, CR plus DR, AS plus DS and AQ, BQ plus DQ. So after adding this, what we are getting? AP plus BP is what? AB plus CR plus DS what? CD. AS plus DS what? AD. And BD plus DQ? BD. BQ plus DQ. BQ plus DQ. BQ plus DQ. AP plus AS. AP is equal to AS, BP is equal to BQ, CR is equal to CQ and DR is equal to DS. ABs, BC, CD and DS. BC. Plus Q, CR plus DR. BQ plus CQ, BQ plus CQ. BP plus CQ, CR is equal to, you see here we have done some mistakes. CR is equal to CQ, CR is equal to CQ, so it will be CR is equal to CQ. So here will be CQ. CQ is BC. Okay. Now, earlier we got in equation number 1, AB is equal to CD. Here it was AB is equal to CD and what? AD is equal to BC. AD is equal to BC. This was equation number 1 and 2. So in place of AB, we wrote AB. In place of CD, we are writing again AB. And in place of AD, we are writing BC. And in place of BC, we are writing again BC. So what we are getting? Twice AB is equal to twice BC. Implies AB is equal to BC. This is equation number 4, 6, 7. So, in equation number 1, we got AB is equal to CD. You see clearly. Try to understand. AB is equal to CD. And in equation number 2, we got earlier AD is equal to BC. Now we are getting that AB is equal to BC. So what can we say from this equation number 1, 2 and 7? This is equation number 7. So from 1, 2 and 7 we can write from 1, 2 and 7 we can write AB is equal to CD is equal to AD. AB is equal to CD is equal to AD is equal to BC. So that is AB is equal to BC is equal to CD is equal to AD. So simply, if in a parallelogram all the four sides are equal, so simply we can say that it is a rhombus. Therefore, A, B, C, D is a rhombus. Prove. If time having, then we can complete question number 13. 12 also remain homework for you. Now we are doing question number 13. Prove that opposite sides of a quadrilateral circumscribe a circle subtend supplementary angle at the center. This is the last question of this chapter, circle. So look at the question. Till then I am rubbing the board. So prove that opposite sides of a quadrilateral circumscribe a circle subtend supplementary angle at the center of the circle. So here we will consider a quadrilateral circumscribing a circle with center O. Circumscribing a circle at center O touches the circle at P, Q, R and S. Like earlier, we will draw a circle. Simply, it is center O. Circumscribing, we are drawing a quadrilateral circumscribing the circle at P, Q, R and S. Simple quadrilateral A, B, C, D. Okay, touches the circle at P, Q, R, S. Whatever we have drawn, let us write. Let ABCD be a quadrilateral circumscribing a circle with center O. Touches the circle where touched at P, Q, R and S. At P, Q, R and S. What is to prove? Now we have to prove that the opposite sides of a quadrilateral circumscribe a opposite sides circumscribe a circle, circumscribe an angle, subtend supplementary angle. What? Opposite sides, this angle, if we draw an angle from AOB, then AOB and COD. AB's opposite side is CD and AD's opposite side is BC. These opposite sides made supplementary angle at the center. That is, if we join OA, OB, OC and OD, then 4 angles becoming. Joining OA, OB, OC and OD, we get angle AOB, angle BOC, angle COD and angle what? AOD. We have to prove that. What is to prove? This angle plus this angle is equal to 180 degrees. We have to prove that these two angles are supplementary, and this angle plus this angle are 180 degree. Is 180 degree. So prove that angle AOB plus angle COD is equal to 180 degree. Or angle AOD plus angle BOC is equal to 180 degree. We have to prove this. Again, you read question. Prove that the opposite sides of a quadrilateral circumscribing a circle subtend supplementary angle at the center of the circle. This side AB subtend an angle AOB, and its opposite side CD subtend angle COD. We have to prove that AOB plus COD is equal to 180 degree. Similarly, AOD plus BOC is equal to 180 degree. Construction. Here one construction. Marking. Here simple construction. Marking. No. OP, OQ, OR and OS are joint. OP, OQ, OR and OS are joined and marked the angle so formed as 1, 2, 3, 4, 5, 6, 7 and 8. 1, 2, 3, 4, 5, 6, 7 and 8. You see, after joining OP, OQ, OR and OS, we will get more angles, and we are marking this other angles as all angles as 1, 2, 3, 4, 5, 6, 7 and 8. Using this, we will prove this angles found by the opposite sides are supplementary at the center of the circle. Now we are proving. You see, minutely proof. Since what is becoming? You see, AP and AS are the what? Tangents of the circle drawn from an external point A. Like this, BP and BQ drawn from B. Like this, CQ and CR from C, and DR and DS from D. Now another property of the tangent is there. We know that earlier we got, simply I am showing, if it is a tangent, if two are tangents, and this is the center, AB, AP and BP are two tangents, okay. If we join OP, then what we got? This angle is equal to this angle. This OP bisects the angle formed by the two tangents at the point of contact as well as the external point. So the lines, we know that the line segment joining the center of a circle and the external point bisects the angles formed at the angles formed at the center joining the point of contact. Points of contact. You see, this angle is equal to this angle and this angle is equal to this angle. This theory we will use here. So this OA is the line segment joining the center to the external point. AP and AS are the tangents drawn from external point A. So what this OA made this angle in two parts, PAS and POS. Like this, here also OB made these two angles are equal. that is simply here angle 1 is equal to angle 2, angle 3 is equal to angle 4, like this angle 5 is equal to angle 6 and angle 7 is equal to angle 8. So therefore we can write, therefore angle 1 is equal to angle 2, okay, for external point A, angle B, angle 3 is equal to angle 4, angle 5 is equal to angle 6 and angle 7 is equal to angle 8. This is equation number 1, this is 2, this is 3 and this is 4. Okay. Now we have to show that what? Opposites, angle formed at the center, that is 2 plus 3 is equal to 6 plus 7, okay, or 1 plus 8 is equal to 4 plus 5. So if we add all these angles, means all these equations, adding 1, 2, 3 and 4, then what is becoming, you will see. We have to show that this 2 is equal to this 2 and this 2 is equal to this 2, that is 2 plus 3 is equal to 6 plus 7 or 4 plus 5 is equal to 1 plus 8. So keeping this in mind, we are adding these 4 equations, adding 1, 2, 3 and 4, we get, what do we get? Simply add left side and give equal to and then add all the right sides. Angle 1 plus angle 3 plus angle 4, 5 plus angle 7 is equal to what? Angle 2 plus 3 not 4 plus 6 and then 8. See clearly? No, not in this way. We'll use another way. You see, if sum of this all angles is what? Equal to 360 degree. In a circle, what is the sum of the angles in the center? What is the angles in the center? 360 degree. So if we add all these angles, so adding now angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5 plus angle 6, then angle 7 plus angle 8 is equal to 360 degree, because sum of the angles at the center is equal to 360 degree. So we can say that in place of 1 we need 2, 3 and 7, 6. Okay. So in place of 1 we can write 1 is equal to 2. So 2 plus 2. Okay. We need 2, 3, 6 and 7, others no need. So in place of 1 we can write 2 plus 2 and plus 3. So in place of 4 what can we write? 3 plus, in place of 5 we can write 6 in place of 6, 6, and in place of 7 we can write 7, and in place of 8 we can write 8 is equal to 360 degree. You see again, in place of 1 we can write 2, in place of 2 we can write 1. We need 2, 3, so in place of 1 we have written 2. Okay, this to finish. Now 3, 4 we do not need 4, so 4 is replacing by what? 3. Then 5, 6 we have no need 5, so 5 is replacing by 6 because 5 is equal to 6 here. Again 7, 8 we no need 8, so this 8 should be replaced by 7. Okay. Now this 2 plus 2, this not 4. This angle 2 plus angle 2. This is the name of the angle. So twice angle 2 plus twice angle 3 plus twice angle 6 plus twice angle 7. So now take 2 common. 2 plus angle 3 plus angle 6 plus angle 7 is equal to 360 degree. Implies angle 2 plus angle 3 plus angle 6 plus angle 7 is equal to 180 degree. 2 plus 3 is equal to angle AOB plus 6 plus 7 is equal to angle COD. So is equal to what? 180 degree. That is means here it was AOB and here it was COD. So AOB and COD are the angles made from the opposite sides of the quadrilateral ABCD. So sum of these two angles is 180 degree. So we can say that these two angles are supplementary. Hence the angles so formed are supplementary. Proved. So this is the end of the chapter. I have given only one homework. I will hope you will complete it. I hope that you will complete it, and if you cannot, you need any help, then you may contact with me. Question number 9 from the whole chapter I have given homework, and question number 6 homework. 6 and 9 I have given homework. This is the end of my class. Thank you.